Hi everyone. This is lesson 4-1, Algebra 1. We're going to start talking about exponents and how to work with exponents, how to um, multiply, divide, add, subtract things with expressions involving exponents. And so our essential question today, we're going to be focused on multiplying exponents. So what does it mean to multiply expressions when exponents are involved? And what are the rules for multiplying expressions with exponents? Okay, so um, let's start with some basic definitions here. So we have 2, and then this number up here, above here, that's called an exponent or a power. This just means 2 multiplied together 3 times. So this means 2 times 2 times 2, okay, which in this case is 8. 2 times 2 is 4, and 4 times 2 is 8. Um, so the reason that we use this way of writing it is just a shortcut. If I had, something like 2 multiplied together 10 times, like that would be really cumbersome to write out. 2 times 2 times 2, right? 10 times. So we have this notation here that we use. We use this exponent to do that. So 2 to the third is equal to 8. This part right here, this number, the 2 in this case, we call this the base. Okay, that's the number that's being multiplied together. And then this term we call either the exponent or the power. Okay, so exponent. And then we also refer to that as the power. Um, we're going to use those terms interchangeably. So when we talk about power, we're just saying exponents, just a different way to say it. Okay, so here we have 2, our base 2 to the third power. 2 multiplied together 3 times is 8. So on a calculator, if we were going to put that in on a calculator, um, so it depends on your calculator, but most calculators, you can do it this way. There's this little, this is called the caret key, this little up arrow thing right here, is for exponents. There's also a little shortcut here for squared. And so if you just need something to the second power, you can type the number and click that and it will raise it to the second power. But this is what we're going to use for any other exponents. And again, it depends on your calculator. The newer calculators actually will display it differently and show it differently. But if I wanted to do 2 to the third power here, I would do 2 as my base and then to my exponent of 3. So 2 to the third power there, and I did that, and that would be 8. Okay. Now, when we have larger ones, right, and we're multiplying together some expressions here, we have some different numbers here that are numbers raised to a power, base raised to a power. We're multiplying those together. So if we look at this, what does this mean? This means 2 times 2 times 2. That's this term times 2 times 2 times 2 times 2. So look at this. We're multiplying 2 together 7 times. So this is 2 times 2 times 2 times 2 times 2 times 2 times 2. It'll be 2 to the 7th power. Okay, and so this kind of brings us to our first rule here. And this says if our numbers, if our bases, right, our base numbers are the same, and we're multiplying exponents, we can just simply add these together. So we could say 2 to the third times 2 to the fourth. That's really the same as 2 to the 3 plus 4. Right? We can add those exponents together. And so how many times will we multiply together? Well, 3 plus 4 is 7. We're multiplying 2 together 7 times. Oops, 2 to the 7th. And we can verify that on our calculator. If I say 2 to the third, and I'm going to put that in parentheses here. Let's do this again. 2 to the third, so my calculator doesn't get confused. 2 to the third times 2 to the 7th. Sorry, 2 to the 4th. we get 128. And if I put in 2 to the 7th, it's the same. So I can verify that on my calculator. Okay, so here's just some definitions here. So we have base and power. So the number we're multiplying together is called the base. The number on the top here, that superscript, that's called the power or the exponent. So this is 2 to the third power. And the product of powers property just simply says when you multiply powers with the same base, right? The base stays the same and you just add the exponents. Okay. So we get, in that example down below there, we get 2 to the second power times 3 to the second power times 3 to the third to the seventh power. Can't read. So we add those exponents together. 2 plus 7 is 9. And so we get 3 to the ninth power. Okay, so notice nothing happens to that base number. That 3 just stays the same. And this just means we're multiplying 3 together 2 times plus another 7 times. We get a total of 9 times. Okay, we look at some examples here. So this just means take this number and raise it to the third power. Now, this expression here is actually pretty poorly written. It's actually not clear. So what is being raised to the second power? Is it the 3 that's being raised to the power, or is it negative 3 that's being raised to the second power? Okay, and so it's not clear. So generally, right, this is the way that we interpret this is we say, well, only the number here is being raised to the second power. So in this case, only the 3 is being raised to the second power. So we could actually write this as negative 1, right, times 3 to the second power. Okay, that's the way that we would interpret that. And what that means is that first we're going to do order of operations. So order of operations says we do exponents first. So 3 to the second is 9. So this would be negative 1 times 9, which would be negative 9. Okay. Now, like I said, this is a poor way to write this. If I wanted to make that clear, what I should have written, or what the example should say, is something like this. Right? That's crystal clear. That says do 3 to the second first, and then take the opposite or multiply that by negative 1. So that's a better way to write it. You actually see some things like this, like on the internet sometimes. You know, like you get these sort of wacky, the internet's stumped by this, basic math problem, that sort of stuff. So it's really, this is just a poorly written example, a poorly written expression. Okay, so this is a better way to write it. And in fact, when we go into our calculator and we try that, we're going to see that the calculator actually interprets this as a different number as well. Okay. This second example here, negative 3 squared. So this is actually saying that the negative gets squared along with the 3. Okay, so this means negative 3 is the thing that's getting multiplied together. So this is negative 3 times negative 3. Negative times negative is positive. This is positive 9. So you see it makes a big difference, right? How we interpret these and how we read these and the rules that apply to them. Like I said, this first one is poorly written. It's ambiguous. The second one is much clearer, and the third one is clear as well. Okay. If we look at that on a calculator, so if I do negative 2 squared, and so if I just type the negative here, right, and this means negative, not minus, so negative 3 to the second power, right? So I have a squared, I can just use this shortcut here. So negative 3 to the second power, you see I get negative 9. If I actually meant that I wanted the negative 3 to be squared, negative 3 times negative 3, I would want to put parentheses around that. Negative 3 squared. So, right, that would give me 9. Okay, if I wanted to be, again, clear, I could say negative and then parentheses 3 squared. Okay, that would give me negative 9. So it's doing the 3 squared first and then taking the opposite of that. And then if I did negative 3 and then I put the exponent on the outside, well, what's it going to do? Well, it's going to go ahead and multiply this 3 together 2 times and then take the opposite. So this should be negative 9 as well. Okay, so see different ways of putting this in give you different results. So you really want to understand how your calculator works. You really want to make sure that you know how to type it in and that it's crystal clear to both everybody and the calculator, right? What your intentions are. Okay, so here's some examples here. If we go through these, this is 4 to the 5th times 4 to the 3rd. So the bases are the same. I can just simply add these together. This is the same as 4 to the 5 plus 3 power, right? Or 4 to the 8th. Now, when you have a number as a base, generally the way to write these and the way that you'll be asked to put these in is not 4 to the 8th, but they'll actually want you to calculate what that value is. So if I go to my calculator here and I put in 4 to the 8th power, so that's 65,536. Okay. 3 times 3 to the 6th. So remember that this 3 is actually, we consider that to be 3 to the 1st power, right? It's 3, but there's only one of them, okay? So that's not a 0, or it doesn't mean it's actually, we treat that as a 1. So 3 to the 1st power times 3 to the 6th power, this is going to be 3 to the 7th power. Okay, we're multiplying 3 together 6 times, plus 1 more, right? So we get 3 to the 7th. And so my calculator, I'm going to calculate that out. 3 to the 7th is 2,187. Okay, and now we get to this tricky one here, right? Again, it's poorly written. This is very ambiguous. But what we saw before, right? This means 2 to the 2nd and the opposite of that, and then times 2 to the 3rd and the opposite of that. So when we look at this, we get, this is -1, right? Times 2 to the 2nd power times -1 times 2 to the 3rd power. Okay, so if we multiply this out, -1 times -1 is +1. Okay. And then 2 to the 2nd times 2 to the 3rd is going to be 2 to the 5th power. And so 2 to the 5th power is 32. Okay, so again, be really careful when you have those negative numbers in front of that, right? We want to square the number first and then take the opposite or multiply it by -1. Okay, and again, so when we have numbers, right, an actual number to a power, we want to go ahead and expand that. But we'll also have variables. Okay, so when we go through these, what we're going to do is we're just going to take all the same bases, right, and multiply them together. Now, here I have 3, all right, and this is a 1 k to the 3rd. So 3 times 1, I'm just going to multiply the numbers together. 3 times 1 is 3. And then if I look at k to the 2nd power times k to the 4th power, that's going to be k to the 6th power. Okay. In this expression right here, only the k is raised to the 4th power. The 3 is not. The 3 is actually to the 1st power. So we have 3 to the 1st times k to the 6th. Okay, here we have multiple bases, right? Here we have some numbers, and then we have an x, and then we have some y's. So these start to look complicated, but please don't make them complicated. We're just going to multiply the numbers together. Okay, follow order of operations. We're going to multiply the numbers together. So 3 times 4 is 12. And then I've got x to the 4th times x to the 1st power, right? So this is going to be x to the 5th power. And then y to the 2nd power times y to the 7th power, that's going to be y to the 9th power. Okay, so I multiply the numbers, and then I add the exponents for each of the variables. And then lastly, we have this one that looks really intimidating, looks really complicated, but we know that we can just kind of do this a step at a time. Take the numbers first. 6 times 2 is 12. And then I've got a squared times a to the third, that's going to be a to the fifth power, so 2 plus 3. And then I have b to the second times b to the seventh, that's b to the 2 plus 7, that's going to be b to the ninth. And then c to the third times c to the ninth, so 3 plus 9 is 12, so that's going to be c to the 12th power. Okay, so don't let these long expressions intimidate you. Just take them a piece at a time, do the numbers, and then add the exponents for all the like bases. So all the variables, right, the same base. Okay, so we're going to wrap it up for today on that. And then next time we'll talk about how to multiply together, how to take a number that's raised to a power and raise it to another power. So we'll go ahead and stop here, and hope you have a good day.